Welcome to The Explainer. Today we are diving into a strange and honestly beautiful branch of math that might just be the key to defending artificial intelligence from a threat that is surprisingly simple and incredibly dangerous. State-of-the-art AI is brilliant, but it has this hidden weakness. It's shockingly easy to fool with tiny, often completely invisible changes to the data it's looking at. This is what's known as an adversarial attack, and it's almost like finding a secret password that makes the AI see the world totally wrong. And look, this isn't just some fun party trick. It is a major security risk. Just imagine for a second the implications. A self-driving car that can't tell a stop sign from a speed limit sign, or a medical AI that misreads a critical scan. The stakes here are incredibly high. So how is this even possible? And maybe more importantly, how do we stop it?
Okay, let's get right into it. The heart of the problem is something called an adversarial attack. It's basically a deliberate, malicious attempt to fool an AI system.
So think of it this way. An attacker is basically an expert at finding an AI's blind spots. They add this carefully crafted layer of, let's call it digital static, to an image. To you and me, the school bus still looks exactly like a school bus. We wouldn't notice a thing. But to the AI, that tiny imperceptible change is enough to completely flip a switch in its brain, leading to a wild misclassification.
And this really matters, because we're trusting AI with more and more critical jobs. Guiding our cars, analyzing our health, protecting our cybersecurity, managing financial systems. Making sure these systems are reliable is absolutely central to our safety. A vulnerability like this isn't just a small bug. It is a potential disaster just waiting to happen.
So how in the world do you defend against this? Well, researchers found a really surprising answer in a field of pure math called tropical geometry. It's this whole other world where the rules of arithmetic are kind of turned on their head. And it turns out it's exactly what we might need to build a stronger AI. Okay, so what is this tropical math? It's based on something called max plus algebra. And the rules are weird. Forget what you learned in school. In this tropical world, when you add two numbers, you just pick whichever one is bigger. That's it. And when you multiply them, that's just regular old addition. It's a completely different way of thinking about numbers.
Now, I know what you're probably thinking. This sounds like some crazy abstract math concept, right? But here's the kicker. This weird math isn't actually so weird to an AI. Researchers figured out that this tropical structure is already deeply connected to how some of the most common neural networks actually work. The connection was just sitting there, waiting for someone to use it.
So, how do we take this strange math and use it to build a stronger AI? Well, researchers use this insight to create what they call a tropical convolutional neural network, or tropical CNN for short. And it's designed to be a fortress for the AI's decisions. And what's so brilliant about this is just how simple it is. Seriously, they didn't have to rebuild the entire AI from the ground up. Nope. Instead, they just took a standard off-the-shelf neural network and added one single specialized layer at the very end. They call it a tropical embedding layer, and it forces the AI to make its final decision using those tropical math rules. Okay, so here's where the magic really happens. It all comes down to changing the AI's decision boundary. You can think of this as the line the AI draws on its internal map to separate one thing, let's say a cat, from another thing, like a dog. In a normal AI, that boundary is usually pretty smooth, kind of like a gentle rolling hill. An attacker can pretty easily find a way to creep over it. But the tropical layer changes everything. It transforms that smooth hill into something jagged and complex, like the facets of a crystal, creating all these hard walls and dead ends. And this image shows you exactly what I mean. Instead of a smooth, vulnerable border, the tropical CNN creates this incredibly complex geometric maze. It's just a fundamentally tougher defense for an attack to try and break through. All right, so that's the theory. But does this mathematical fortress actually work in practice? The researchers put it to the test, throwing one of the toughest, most effective adversarial attacks out there right at it. They used the classic MNIST dataset, the one with all the handwritten digits. And the results? Just look at the numbers. Under this powerful attack, the standard model just completely collapsed. But the tropical CNN's performance? Well, it's a night and day difference. Let's just focus on that for a second. The standard AI failed over 99% of the time. It was basically rendered useless. Any confidence you could possibly have in its decisions is just gone.
But the tropical CNN? Its error rate was just under 6%.
That is a monumental improvement. It held strong and kept its composure right where the standard model completely shattered.
So what is actually going on here? Why does this specific mathematical defense work so incredibly well against this powerful kind of attack?
This visualization really tells the whole story. The attack works by following the path of least resistance. It's called the gradient. Think of it like a ball rolling down a hill. The red arrows show the path the attack tries to take to fool the AI, but that tropical boundary creates a landscape that's full of walls and dead ends. Those are the green zones you see. The attack just gets stuck. It hits a wall, the gradient goes to zero, and it just can't find a path to its target. It's totally thwarted by the geometry.
All right, let's wrap this up and talk about what this all means for the future of AI safety and security.
Well, this method gives us a huge security benefit without all the usual trade-offs. It's simple to implement, it's efficient, and it doesn't slow things down or make the model bigger. In the world of AI development, that is a massive, massive win.
As the researchers themselves put it, it's an elegant solution. And it's just a perfect example of how abstract, seemingly esoteric math can provide a practical and incredibly powerful defense for our most cutting-edge technology.
And it leaves you with this final, fascinating thought. If a field like tropical geometry can solve a problem this critical, it really makes you wonder, what other unconventional tools, what other weird ideas from the world of science and math are just waiting out there to help us solve our most complex problems and build a better, safer future?